See, basically, we can do one thing. I will take a class or other teacher will take a class for the electric component, basic electric component, so that you will be familiar. Are you, all of you are not familiar with resistance, capacitance and inductors? From the CSC students, I am asking that thing. Are you not familiar with? I know, sir. Ravi Prakash says, I know, sir. Okay. Other CSC persons? Forgot inductor. See, we can do one thing. We can take a basic class on that one if you want. But I don't think it is required here, because in this exam they will not going to ask you that how to solve that inductor, resistor, and capacitor things, right? If you are having a basic idea that we are having a resistance, capacitance and inductors, right? I will tell you how we can utilize that thing, right? How we can utilize that thing, and we will discuss that thing here. Like if I'm having resistance, how it will be converted in frequency domain. So if you remember that thing, that will be better for all of you, right? No need to go in depth for that exam, because in this exam, in this BSNL exam, they are not going to ask you the question for numerical solving and all of that one. They are only asking the questions from the basics, that you are aware about the basics of this thing or not. Understood? So basically my main thing, the main discussion about this one, if you want, then we will take the separate class for the basics of that one. No, there is no past paper, right? There is no past paper for this exam, because this time they are recruiting for senior engineer. From the last last years they are taking, from last to last year they are taking for from the gate, that is JTO, Junior Telecom Officer, the BSNL recruiting for that one, right? And this is for senior officer post. So this is the first time he will conducting the exam, and the syllabus is also different from the gate and other exam. So if you are preparing for this exam, you are having the advantage, because everyone, see, if anyone is preparing for gate, that will not familiar even a single subject here. Like if I'm discussing signal processing is also not a part of your gate exam. So the person who is preparing for gate and any other exam, that is irrelevant for this exam, I can say that thing, right? So if you are going for this BSNL exam, and you are preparing for that one, you are having more advantage from the others. अंडरस्टूड? मैं क्या बता रहा हूँ भाई, आपको बहुत बड़ा एडवांटेज है अगर आप इस एग्जाम की प्रिपरेशन कर रहे हैं, क्योंकि बाकी बंदों ने भी इसको नहीं पढ़ा होता, जो गेट की प्रिपरेशन एक एक साल से कर रहे हैं, सब आप ही की जगह खड़े हैं. Everyone is standing on same places right now, right? If you start preparing, you are putting efforts towards this one, so this exam will be easy for you, because the competition in this exam is not like that the persons which are preparing 2 or 3 years, right? They are having the advantage. No, because this syllabus is completely new to everyone. Understood or not? So this syllabus is, yes sir. Yeah, because this syllabus is completely different from other exams, so no one have the advantage. Everyone is standing at the same place. So if you are, yes, everyone is the same level. Everyone, even if he is from electronics background, right? Electronics background person has little bit advantage, that they are aware about this antenna and all of that stuff, but they are also not dealing with these things when they are preparing for gate and other exams, the state level exam or any PSU exam. That is completely different from this BSNL. Yes, MCQ, basically first I will cover these topics, then I will take the classes for MCQ. Right, I will take the class for MCQ also, and we will provide you practice questions also. And YourPedia will also going to launch a book for that one, right? For your question practice. Don't worry about that one. Question practice we will do for each of every subjects. Is this core electrical stuff are only in the signal processing model? Will also be, no, not other. Like in signal processing and communication part. Communication is also there, right? In the first chapter there is a communication, modulation and demodulation is also there. Rest are new for everyone, right? You are from electrical or electronics, CSC or any background, everything is new for everyone, right? So if you are preparing for this exam, just do one thing: put your full efforts. And if you are putting your efforts, right, in right direction, which you have to prepare, right? Which topic I have to prepare and how much depth I have to go. If you go in that direction, because when you see this syllabus and search even a single topic on Google, right? Let us take, you are searching on signal processing on Google. So what you get? You get definitely more and more stuff. He just write a single word, signal processing. He didn't specify that which topic you have to cover under this signal processing. Right. If I'm going to the second chapter, that is wireless communication, wireless telecommunication. In that one, he just put a single line about every topic. So basically, for that exam, it is required that at how much depth we have to study every topic. Did you get my point? So this exam is purely based on a strategy that in each and every topic, how much depth is required from where he can ask the questions. If you even a single search that fundamental of 4G, you will get around 400 pages books for 4G network, but that is irrelevant for you, right? So basic thing is that how much you have to study. यस घनश्याम, यूट्यूब में तो मिलेगा ही नहीं यार, क्योंकि हो क्या रहा है घनश्याम जी, यहाँ पे पूरा का पूरा टेक्निकल पार्ट जो है, ये जो है करंट में जो बीएसएनएल में चीजें चल रही हैं उसी से रिलेटेड उठा के उन्होंने डाला है। जो आप लोग ट्रेनिंग में जाके पढ़ोगे वही सारा सिलेबस उठा के उन्होंने डाला हुआ है यहाँ पे, जो एक इंजीनियर के लिए रिक्वायर्ड है। which thing is required for a telecom engineer, they already put it in the syllabus so that you will be familiar with that one. Previously, they are asking the questions from your BTech curriculum. In your BTech curriculum, we only studied the, if I am talking about electronics engineer and CSC engineer. CSC engineer only studied only that computer network here. They are not studying all of this stuff. And from electronics point of view, we just study the mobile communication. We didn't study 4G, 5G, and the computer and the network, Bluetooth, and all of these technologies in our BTech curriculum. So they put that thing in this exam syllabus so that you are well prepared or prepared before the exam. So that's why in this exam, you are having a real advantage. Has mobile computing. That mobile computing is different from mobile communication. Mobile communication means how we can connect a call from one place to other place, how we can send the information or data packets from one place to other places. That is mobile communication. Mobile computing is different from that one, Abhinav. So my main thing is that you have to be more focused. Don't waste your time. Don't waste your time to get extra knowledge from here and there. Just focus on that thing which we studied here. That is more than enough. And at the final, in the final, when you give the exam, you will realize that everything will be the same which we studied here. Right? It will be the same questions will in your exam. Will be understood? Any doubt about this one? And from CSC background persons, if they have any doubt in any question, they can ask right now here. If it is not clear, then just message me. You already have my WhatsApp number. You can just drop a message to me, right? I will clarify there also. And if it is required, we will arrange a separate class on Saturday or Sunday for a CSA background person or any persons who required anything, right? We can do one thing for that thing. Okay, let's start the class, or any other doubt you can ask right now, then I'm going to start the class after that. Yes, please. Okay, my mobile number is 70176369. 179. Yes, but for that one you have to give me the requirements. What are your requirements for that class? Right, Asmira? What you want from that class? That sir, I we are having the like CSC background person are not aware about that resistor, capacitor and inductor, all of that thing. Then we can arrange the class on that ones, right? So in that class we can discuss the basics of current division rule, voltage division rule, resistance, capacitance, resistance in S domain, frequency domain, like that. So you just tell me the requirement for that special class, we will arrange that one also, right? Any other thing? Yes, please ask. यस, आज का ओवरव्यू दे दीजिए। ओवरव्यू देंगे मैम जी, अभी करेंगे स्टार्ट, फिर ओवरव्यू मिलेगा आप क्या स्टडी करने वाले हैं। पहले नॉर्मल डाउट है, हाँ जी। यस प्लीज, एनी डाउट? What will be the total number of lectures delivered for this model? See, basically, like for this DSP, digital signal, oh sorry, this signal processing, I am planning to have the 7 to 8 classes. But yesterday I this is the you can say half lecture we covered yesterday. So because I'm starting with the slow pace, and most of the persons are not aware about these things, that's why it is taking time. But hopefully 7 to 8 lecture I will cover this DSP, this signal processing, not DSP, signal processing, right, like that. So overall we are planning to complete this module before 15th of March, right? Or you can say on 15th of March we will completely cover this syllabus. Because after this you will get a parallel class for computer network also. I think today evening you will get that class. 6 to around 7:30. I don't remember the timings. Timings is already shared with you. So today onwards you are getting the computer network class also. Sir, signal system completely syllabus included in basic telecom. No, signal system is not completely included in that one. In that part, see, I'm again saying, because signal system is, you can say, the vast subject, and that is irrelevant. Don't waste your time on that one. Complete signal system. Just focus on the basics, which I discussed here yesterday. What is the first thing? That is impulse, signal processing, basic idea, and what is filtering. Because we are going to discuss today also about the filters, right? So basic telecommunication topics will not include signal and system, complete signal and system. What it will include, I'm going to discuss here. Understood? Yes. Anyone else? Should we start? Yeah. See, you can do one more thing. If you are having any doubt, you can just unmute yourself instead of typing. You can just unmute yourself and you can ask the questions, right? It is also a good practice, because that will make this class, you can say, two-way, not one way, from my sides only. Okay, let's start this. Continuous LTI system in time domain response. So yesterday we discussed about LTI system, linear time invariant system, right? Just remember the names of these things, like LTI system. If you are from CSC and any other background, just remember the names what I'm telling you. LTI means linear time invariant system. Everything is written here, but you can make your own short notes, right? This PDF is also provided to you. That is more than enough, but sometime I'm saying something extra, right? You can write down in a short note form on your own notes, right? Or I will share this file with you, and you can write that thing on the right side or left side of that one, that this is the extra information which sir gave in the class, so that if they ask that thing, you can easily decode that one. Got it? So just make your short notes also. लाप्लास वीक है थोड़ा, उसके कॉन्सेप्ट से हो जाएगा। या इफ योर लाप्लास इज वीक, डोंट वरी, आई एम डिस्कसिंग दैट वन हियर, विच इज रिक्वायर्ड फॉर दैट वन। I'm not saying that I'm not discussing Laplace, Z transform or Fourier transform or Fourier series. I also discuss these things here, but if you are prior having little bit knowledge about that one, then it is easy for you to it is easy for you to understand the things here, right? Sir, please give some question or assignment in the question for to help. Yes, I will provide you the assignments after each topic. Don't worry about that one. And that assignment will also have questions and with answers. Right, questions and answers are also there. So I will provide you the assignment after each topics, right? When we cover this complete topic, then I will provide the assignment. When we'll cover each topic, like lecture 1 or lecture 2 combined, I will give you one assignment which is having 30 to 50 questions, so that it will be easy for you to understand the things, and you will understand that which type of question they will going to ask you. Yes, next. सर कितनी क्लास होंगी हर सब्जेक्ट की? See, it will not be fixed that every subject has that much class. We plan to cover this complete syllabus up to 15th of March. If it is required, we will provide you extra classes also, right? Anything else you want to know? And do one more thing, just put your name, like your name is Realme Pad, just rename your Zoom ID with your real name, so that I will understand that this person name is that one, right? Okay, should I start? Yes. Okay, now what you are seeing, my our main concern is what you are having a system here, right? Let us take it. You are having a system. This is our system S, and we will give the input xt here to this system. This is input, this is input, right? This is a system, we give the input as xt, and this system is represented by its impulse response, that is h of t. Remember, sometime he asks you that what is the h of t. Remember the name of h of t, what I yesterday taught you, that it is what? Impulse response. So we know that this is a system whose impulse response is this one, and its input is xt, and we want to calculate its output yt. Its output yt. This is our main concern. That which response or which output it will produce for input xt. Should I repeat? Understood? So basically this input, this is impulse response of this system. Impulse response of this system. Then the output of this system is yt. Now, how much is the output of this system? Remember, the output yt will be equals to xt. That means convolution. This star is not multiplication, it is convolution, right? So it will be equals to xt convolution with h of t. So this is the output of an LTI system whose input is xt and impulse response is ht. Now you got this, that output of any LTI system will be the convolution of input xt and impulse response st. Then how we can calculate this convolution? So this convolution have the formula y of t is equals to integration minus infinity to infinity x of tau h of t minus tau d tau. So this will be the formula for convolution, that is equals to integration from minus infinity to infinity x of tau h of t minus tau, right? Another formula which is equivalent to this one, that is yt is equals to, you can interchange x with h, so it will become integration minus infinity to infinity x of t minus tau h of tau d tau. You can interchange both of them, x and h, right? So this will be the formula for what? the output YT, which is convolution of input XT and HT. So these are the two formula for the convolution. So how he can frame the question? He can frame which of the following represent the convolution, and he will provide you the any one of them for any one formula from these or these two, right? So you have to be more focused on that one. What is the formula for the convolution? Understood everyone? So main thing is about that when you are giving the input xt to a system S which is having impulse response st, then its output will going to be yt, and that yt will equals to the convolution of input xt and impulse response ht, right? Okay, so if I'm talking about convolution is and not means you can say any mathematical tool or anything, it's just a formula. This represents the convolution, this formula represents the convolution, right? It's just a formula to calculate the output. We give this formula as a name, which is convolution. Understood, Abhinav? So these are the two formulas which you have to remember. Both are same, right? It means what we can say that yt is equals to integration minus infinity to infinity x of t minus tau h of tau d tau is equals to integration minus infinity to infinity x of tau h of t minus tau d tau. These two quantities are equal to each other, right? Okay, yes, this is convolution. Now here we discuss how we can make a convolution of two functions, right? Basically this is a graphical representation. First thing what you are observing here, we have to calculate, let us take yt, that is equals to integration minus infinity to infinity x of tau h of t minus tau d tau. Now what you are seeing here, this is the impulse response of the system. This is given to you. This is the impulse response of a system is given to it. Just try to visualize that thing, that this is the impulse response which is given to us. Now in the this convolution formula, what we are having minus of tau. Here the variable is tau, t is fixed to us in this convolution. Tau is variable because we are integrating with respect to tau, right? So tau is variable and t is the fixed quantity, remember that thing. Now if I'm going to draw the graph of h of minus tau plus t, just one thing you have to note it down, because in signal system basically you understand, you have that thing, that if I'm having scaling as well as shifting, there are two operations. One is scaling, another one is shifting. Scaling means what? Let us take, you are having, yesterday I already discussed that thing, that from minus 1 to 2 I am having a signal xt, right? Now if I draw xt plus 2 graph, this is called what? This is called shifting, right? This is called shifting. When you are adding or subtracting something from the t, that is called as shifting. Now scaling means what? If I do x of 2t plus 2, right? Here what we are having the combination of what? Shifting plus scaling. So if you are having a combination of shifting plus scaling, then sir, what we have to use first? Okay, before moving to this, let me discuss what is scaling. Now this is your xt graph. We have to draw the graph of x of 2t. X of 2t means scaling. Scaling means what? That all the values of time, just remember that thing. If you are doing the scaling means what? You have to divide all the values by 2. If you are having 2t here, then you have to do what thing? We have to divide all the t values by 2, and we will got the graph of x of 2t. That will be minus 1 by 2 and that is 1. So x of 2t graph is from minus 1 by 2 to 1. So this is called compression. We compress the signal. The original signal x is lying from minus 1 to 2, and when you compress that signal, it is going from minus 1 by 2 to 1. Understood everyone? So this is called scaling. Right. So scaling are two types. This scaling means what? We compress the original signal. Right. Another one is expansion. Expansion means what? If I draw the graph of x of t by 2, x of t by 2 means what? These all values of t will multiply by 2. Remember that thing. So if I want to draw the graph of this one, multiply by 2. Multiply by 2. Minus 2 to 4. So this is called expansion. So there are two types of scaling. One is compression, another one is expansion. This is the part of signal system which you have to know. So basically yesterday I already discussed shifting. Today I already discussed scaling. Any doubt in this scaling concept? Scaling again two type, compression and expansion. When you do 2t, it means you are compressing the signal. You are removing the width of the, reducing the width of that signal. Okay, what you want, Karna? That is x of 2t is equals to minus 1 by 2 to 1 area. No, not area. Area is not going to change. Means area is going to change here. Its amplitude is 1, its amplitude is remain 1, but its width is reducing. Previously, its width, if you go for original signal here, if you go for original signal, how much is the width of original signal? How much is the width of original signal? The original signal is lying between minus 1 to 2, right? And if you go for x of 2t, x of 2t, then it is going from minus 1 by 2 to 1, right? Its width is going to be how much? How much it will be reduced? It is from minus 1 to 2. This time its width is 3, and here its width is going to be 1.5. So width is reduced to the half of previous width. So it will reduce the width of that signal. Area, yeah, definitely area will change here. Area will not remain same. Understood? So that's why it is called as compression. Now, if you go for expansion, we are expanding the signal in time domain. We are expanding the signal in time domain. It means this signal from minus 1 to 2 now become minus 2 to 4. Width is expanding, but amplitude remains same. Amplitude remains same. That is one. Is that clear to everyone? Yes. Okay, so this is shifting scaling. Now come back to here. Yes, one more thing which we have to discuss, which we are going to discuss here, that if you are having a combination of these two, if I'm having a combination of shifting as well as scaling, then what should I do? Which one I have to perform first to get the correct result? Yes, can anyone tell? Mayank, scaling first. Yeah, other than Mayank, anyone? There are two operations. One is shifting, another one is scaling. So which we have to perform first? See, basically whenever you are having the combination, the natural order which you have to perform here, that will be shifting first. Remember, whenever you are having the two operations, shifting as well as scaling, then you have to perform shifting first, then you have to do the scaling. First shifting, then scaling. Got it? Now, let us take in this example, we want to draw the graph of x of 2t plus 2. We want to draw the graph of x of 2t plus 2. So that will become how much? First, I want to draw the graph x of t, then we have to draw x of t plus 2 first. T plus 2, always. Then it will become from where to where? Minus 3 to 0. This is x of t plus 2. After doing this, you have to do the scaling. After this, you have to do the scaling. Now, if you want to draw the graph of x of 2t plus 2, that is become from minus 3 by 2 to 0. That is x of 2t plus 2. Check. I think everyone understood that thing. Right? So first we do the shifting, then we will do the scaling. So same thing we will do here. This t in this ht, this t is constant. So we can write this term as h of minus tau plus t. So first we do the shifting, then we will do the scaling by minus 1. Scaling by minus 1 is generally known as time reversal. Scaling by minus 1 is generally known as what? Time reversal. Time reversal means what? Let me discuss it here. Again, the same signal which we take previously from minus 1 to 2. This is your xt signal. If you do the time reversal means x of minus t, then time reversal means what? You have to reverse the time. Yes, we will go to the convolution part again. Don't worry. First, I am discussing these things. So the basic operation which is required for convolution. Right, Ravi? So basically, time reversal means what? That 2 is become minus 2 and this 1 is become minus 1 is become plus 1. So they reverse these values. Right? So these are the operation which is really important for this signal processing. And you always remember them. I discussed only how many operations? The first one is what? Shifting. Shifting are two types. The one is advance and another one is delay. When you are seeing x t plus t naught, that will be advance, and when you see x of t minus t naught, that will be delay. Another operation which I discussed with you, that is what? Scaling. Scaling again two type, that is compression and expansion. If you are having x of 80, x of 80, this is compression. If I am having x of t by a, this is expansion. And the third one which I discussed here, x of minus t, that is known as what? Time reversal. Time reversal. Right? Now we are going to this convolution. Right? So this is where the system, yeah, here we are having the system. This is the LTI system with it is having an input. Again, it is having an input, it is having an input u of t, its impulse response is h of t, and we are getting the output yt, which is a convolution of these two terms. Right? He take that ut is a triangular signal like this. This is a triangular signal and this is our h of t. So if I go for the formula, that will be integration from minus infinity to infinity x of tau h of t minus tau d tau. Now this x of tau means only one thing what you have to do, because input is ut, so in place of t I just replace the tau. So it just replace the tau in place of t, right? Now I want to draw the graph of h of t minus tau. So the first thing, h of t graph is given to you, h of t graph is given to you. So first thing, just replace in place of t, just replace the tau. So this is become h of tau graph. This is become h of tau graph. What we did? Just replace the t with tau. Now after doing this, we have to draw the graph of h of tau plus t. Tau plus t means what? Just focus here what I did, what I'm going to do. T, tau plus t, because this axis is tau and we are adding the t into that one. It means this t will be shift the graph towards the left by how much unit? T unit. So it means this graph will start like this, from where the lower limit will become minus of t. After that, because we have to draw the graph of h of t minus tau, that also be written as h of minus tau plus t. So we already draw the graph of h of tau plus t. Now after that we have to do the time reversal, because we want to draw the graph of h of minus tau plus t. So just do the time reversal here. If I do the time reversal, this graph will be look like this one, and this value is now become t, right? So this graph is h of minus tau plus t. Should I repeat this or understood everyone what I did here? Yes, please just let me know. First we do the shifting. We just, what we do, just h of tau graph, just shift that graph towards the left by t unit. Now after that what we did, because we want the graph of h of minus tau plus t, what we did, we just do the time reversal. Time reversal means what? The negative cycle will become positive side, means the negative side will go to the right side and right side will go to the left side, or you can say just make the mirror image about the y axis. If you want to do the, if you want to do the time reversal or h of minus tau, just make a mirror image of this graph about y axis. The left side go to right side, right side will go to the left side. Understood? Now we will go to the graph of h of minus tau plus t. After that, what we have to do for this convolution, that we have to multiply these two terms. The input multiply with this h of t minus tau. So we will go to multiply them. So when you want to multiply this one with this one, so now what will become? See, the multiplication of these two quantities will become like this. How we multiply that? Can anyone tell me? See, from minus infinity to 0, minus infinity to the 0, this function u of tau value is 0. When you multiply this one with your h of minus t plus tau, that is also become 0 for minus infinity to 0. So what you are seeing here, from minus infinity to 0, this complete graph is become 0, right? After that if you multiply that one, so this multiplication with this one from here to here, this will results a value that will be look like this one up to t1, right? T1 will depend on this t, right? T and this t1, let us take. Got it? So now you multiply them. After this t1, again the value becomes 0. After this t1, again value becomes 0. Now after this multiplication, we have to integrate them. Integrate means what? We have to take the area under the curve. Area under the curve. Now this will be your output. Area under the curve. Right? So no need to go in that much depth how we multiply, how we calculate them. Just understood the basic procedure of that one. He will not going to ask you that you have to find the convolution of this one. He give you two signals and he will want you that you have to solve the convolution of that one. No. In this exam, he only want that you know what is convolution and how it will perform. Everyone understood that one? So no need to go in depth of this convolution. Just remember one thing, that if you are having a system whose impulse response is st, input is xt, then its output will be the convolution of input and input and the impulse response, right? Okay, this is convolution. Any doubt in this one? Then please ask. Yes, please. Anyone have any doubt? Then please ask about this convolution. Yes, you have to remember the formula. Okay. The formula is important, but the basic idea about the convolution I already give you that. Okay. Next thing is what sinusoidal response of an LTI system. Right. Whenever we are talking about the sinusoidal response of any LTI system, sinusoidal response, what do you understand from the name sinusoidal response? Plus or minus. What plus or minus, Ravi? What you want to know about plus and minus? What do you understand from sinusoidal response? Anyone? Sinusoidal wave. These are the general formula. That how we can represent a sinusoidal signal in terms of complex exponential, Euler's formula generally known as, right? When you are having a sine wave, sinusoidal wave, sine wave, sorry, that can be represented e raised to the power j omega t minus e raised to the power minus j omega t divided by 1 by 2j. And when you have cos omega t, that can be e raised to the power j omega t, e raised to the power minus j omega t divided by 2, right? Yeah, sine or cosine waves. See, basically, whenever we are talking about sinusoidal response to any system, sinusoidal response means what? You are having a system S, we are having a input xt here, and it is producing the output yt. But this time, if your input is sinusoidal in nature, if my input is, let us take a sine of omega naught t plus phi, this is the input to this system, then what will be the output of that system? That is generally known as sinusoidal response of the system. Understood what is sinusoidal response? So whenever we are talking about LTI systems, just remember one thing. If you are having an LTI system, this is an LTI system which is having impulse response st, and we give the input as a sinusoidal signal a sine, it can be sine or cosine, sine of omega naught t plus phi, then the output of that system is also a sinusoidal signal of same frequency. I'm repeating the thing what you have to remember, because he can make the question on that one. That if I am having a sinusoidal signal at the input of a LTI system, then what will be the output of that one? The output of this LTI system, this is LTI system. The output of this LTI system is also sinusoidal signal of same frequency. What will be the difference then? There will be a difference in amplitude as well as in phase. So the output of that signal now become a times h of omega naught magnitude multiply by sine of omega naught t plus phi as it is, then the phase of that one h of omega naught will be added with that one. So what we can say, just write down one statement here, that what was that? If you are having a sinusoidal signal at the input of an LTI system, its output is also a sinusoidal signal of same frequency, but its amplitude will change and its phase is also going to change. How much phase change? That will be angle of h of omega naught. And how much is the magnitude? The magnitude of h of omega naught multiplied by a. So that will be the sinusoidal response of an LTI system, which you have to remember. Any doubt in this one? Or should I repeat anything? Yes, please. I think it's clear to everyone. Okay. So that will be your sinusoidal response to that system. Let's do one example for that one. This is the derivation, no need to go in that derivation in that. Yeah. This is a RC circuit. This is a RC circuit, right? We have to calculate the output voltage to that system when you are having an input voltage, right? So basically first thing what we have to do, we have to calculate V out of j omega divided by V input of j omega. Our main task is that one. That is only known as h of omega, which I discussed in the previous example, sinusoidal response. Output V out of j omega divided by V input of j omega. Just try to focus here, right? One thing you have to remember, that I'm going to convert this circuit into frequency domain. This is for everyone, either you are from CSC or any background. Just remember three things about the RLC circuit, that if you are converting them into frequency domain, then what happen? If you are having a resistance, resistance remain resistance, means this is R, this is also R. If you are having a capacitor, right, you are converting that capacitor C in frequency domain, that will become 1 upon j omega c. Omega is the input frequency. And if you are having the inductor, inductor will be replaced by j omega L. So these are the 3 points. The first point, if you are converting any circuit into frequency domain that are having R, L and C, so what should we do? Resistance remain resistance as it is. The inductor will be replaced by j omega L. Just remember that. Inductor will be replaced by j omega L. Capacitor will be replaced by 1 upon j omega C. Capacitor will be replaced by 1 by j omega c. Now I'm going to make this circuit in frequency domain. So what is happening? resistance, capacitance, and here we are taking the output. This resistance remain resistance, this capacitance will be replaced by 1 upon j omega c. Here the input become V input of j omega, that is going in frequency domain, and this output will become j omega. Right? Is this circuit clear to everyone or not? I'm asking to CSC guys, the persons which are having CSC background. Did they understand or should I repeat this? Yes, please. Should I repeat this, Abhinav? Or is that clear? Any doubt? I think everyone understood this thing. दोबारा बताना है. Right. Okay, Abhinav. See, we are converting this given circuit into frequency domain. ये जो given circuit है इसको हमने frequency domain में convert करना है. ठीक है भाई. तो सबसे पहला काम हमने क्या करना है यहाँ पे, अपने को एक रेजिस्टेंस दिख रहा है. जब भी आपने फ्रीक्वेंसी डोमेन में जाना है, ये तो पता ही होगा कि रेजिस्टेंस कैसा होता है. ये रेजिस्टेंस होता है, ये कैपेसिटर होता है और ऐसा अपने पास इंडक्टर होता है. दोबारा से देखिए, तो रेजिस्टेंस को जब आप फ्रीक्वेंसी डोमेन में लेके जाओगे तो रेजिस्टेंस चेंज नहीं होगा. रेजिस्टेंस रेजिस्टेंस ही रहेगा, एज इट इज, आर का आर ही रहेगा. अगर आपके पास कैपेसिटर आपको कहीं दिख रहा है तो कैपेसिटर को हम लोग रिप्लेस कर देते हैं भाई 1/j⍵c से. कैपेसिटर चेंज हो जाता है. कैपेसिटर क्या बन जाएगा, पहले टाइम डोमेन में जैसे मैंने टी लिखा हुआ था यहाँ पे साथ में, तो टाइम डोमेन में कैपेसिटर सी था, फ्रीक्वेंसी डोमेन में क्या बन जाएगा 1/j⍵c. अगर मेरे पास इंडक्टर है, इंडक्टेंस उसका एल दिया हुआ है आपको, तो इंडक्टर जो है वो क्या बन जाएगा, j⍵l बन जाएगा फ्रीक्वेंसी डोमेन में. अब ये चीज समझ में आई? पहले 3 पॉइंट बताओ, 3 पॉइंट समझ में आए कि नहीं आए? Yeah, everyone understood these 3 points, that resistance remain resistance, inductor become j⍵l in frequency domain, capacitor become 1/j⍵c in frequency domain. Yes, just please. Yes. Okay. You understood the conversion of component. Now I did one thing, I did only same thing here. What we did, that V input, because it is in time domain, that is also become in frequency domain, that Vi j omega. Resistance remain resistance. Frequency domain means what you are converting. See, there are two domains when you are when we are discussing about signal processing. Generally, we are dealing with two domains. One is time domain, another one is frequency domain. Right? Okay. Let me give you a brief introduction about the frequency domain. What is frequency domain? Frequency domain means what we are trying to understand that. See, one thing you already know, that every signal has some frequency component. What you understand, that we are sending a frequency 50 hertz, 60 hertz, 120 hertz. So every signal has its has frequency component inside that one. So whenever we are converting one signal in time domain to frequency domain, so what we are doing, we try to analyze that signal, that which frequency component it will have. Right? So the frequency domain means what? We are studying about the frequency, which component, which frequency is available in that signal. Understood? So here what we did, we just convert this into frequency domain. This is omega. Omega is generally known as angular frequency. Angular frequency. Omega is what? That is 2 pi f, which you studied in your degree, not degree, in 12th. That is angular frequency. This is frequency. So we convert this time to frequency. Time to frequency, right? So your omega is 2 pi f. That is conversion of time domain to frequency domain, so that we will study that which frequency component is available here or which one is not. Understood this one now or not? Yes. Now after doing this, there is another thing that is called as voltage division rule. Are you aware about that or not? If you are having two resistance like R1 here, R2 here, and here we are having V1 voltage, and we have to calculate the voltage across this R2 resistance. So what we have to do, we are applying the voltage division rule, that voltage across R2 is V2, that will be R2 by R1 plus R2 into V1. V2 is equals to V2 is equals to R2 by R1 plus R2 into V1. This is called as voltage division rule. Whenever you see two resistance and we want to find the voltage across this R2 resistance, then what we have to do, that voltage across this R2 resistance is V2, which will be what? R2 divided by sum of these two resistances into total voltage V1. Right? This is called voltage division rule. The same thing we are going to apply here, that we are calculating the voltage across this part. So what should we do? That the voltage across this one V out of j omega will be, this will come in the numerator, that 1 upon j omega c is in numerator divided by r plus 1 upon j omega c. So when you take the LCM, cancel out each other. So it is become 1 plus 1 plus j omega rc times V input of j omega. V input of j omega. Now V out upon V input is going to be 1 upon 1 plus j omega rc. And this is generally known as h of omega. So this will tell you h of omega. Now, okay, can anyone tell me, if I'm having a number, the complex number z, that is having 2 plus 3j, right? So it will have two things. It will have, one is magnitude, another one is its phase. How much is the magnitude of this one and how much is the phase of this one? How we can calculate that one? The complex number z is equals to 2 plus 3j. We want to calculate its phase and its magnitude. How we can calculate that one? This is a complex number. Z is equals to 2 plus 3j. How you can calculate its magnitude and its angle? Yes, please.
मैग्नीट्यूड √9 होगा सर, नहीं 13 होगा।
Okay, Mayank, real part is amplitude. No, real part is not amplitude.
सर अंडर रूट करके जो निकालेंगे ना,
I'm talking about magnitude, not amplitude. हाँ जी, क्या कह
तो
रहे कंसर?
अंडर रूट 13 आएगा सर एम्पलीट्यूड।
मैग्नीट्यूड या एम्पलीट्यूड?
एम्पलीट्यूड
एम्पलीट्यूड। और फेज
3/2 आ रहा है सर, √3/2।
√3/2।
टेन इनवर्स 3/2 आएगा सर।
करेक्ट। If you are going for the magnitude of that one, magnitude of z is going to be under root of real part square plus imaginary part square, right? So that is become under root of 4 plus 9. This magnitude is going to be under root of 13, right? This is 9. And if I go for the angle of z, that will be tan inverse imaginary part is 3 and real part is 2. See, this part is known as real part, any complex number, and this is imaginary part. And if you calculate the magnitude, that will be under root of real part square plus imaginary part square. So what we did, we got under root of 13. And if you calculate the angle or phase of that one, that will be tan inverse imaginary part over real part, right? And if you want to represent this form of this complex number is known as what? Rectangular form. If you want to represent that one into other form, that is polar form, how we can represent? That number can be represented with magnitude of that one e raised to the power j angle of z. So this is your another form. Which form is this one? Polar form. Right. So in polar form, how we can represent this 2 plus 3j? We can represent this 2 plus 3j in the polar form as under root of 13 e raised to the power j tan inverse 3/2. Right? Now the same thing is happening here. We calculate h of omega. That value is 1 plus 1 upon j omega r and c. If I take the magnitude of this number, how much is the magnitude? Yes, please.
सर 1/√, में 1 का स्क्वायर प्लस और इन सब का स्क्वायर j ω r c का स्क्वायर।
जे भी आएगा साथ में भाई।
मतलब सर वो फिर -1 हो जाएगा।
What we did here, I says that real part का square plus imaginary part का square. Imaginary part is here 3. Only 3 square. Don't go with this j. Right? J is not the imaginary part. The imaginary part is the multiplication factor of that j. So if you are taking the magnitude of this one, that is 1 square plus omega rc square only. Omega rc square, right? And if I go for the phase angle, the phase angle can be written as in the down, that will be minus j tan inverse of omega rc divided by 1. So when you take this one in the numerator, this one in the numerator, then magnitude of h of omega, sorry, not magnitude, I'm writing that one, the complete h of omega here, because we cover the phase and as well as the magnitude. So magnitude of h of omega is 1 upon under root of 1 plus omega rc whole square, and angle of h of omega is going to be, when you take into the numerator, that will be minus tan inverse omega rc. So this is angle, this is magnitude. Understood how we calculate the angle and the magnitude of this one, this transfer function h of omega. Clear to everyone or not? Clear. Right. So after that, we will try to find if I put the zero frequency, means omega equals to zero in this given two values, magnitude and angle. So what we are getting, that magnitude of h of omega is become 1 when your omega is 0. Angle of h of omega is how much? That is going to be when you put 0, 0 degree. Right, I'm trying to draw the graph of this one, that magnitude graph separately. H of omega. Right, here we are having the omega value on this axis. So when I put omega equals to 0 into that one, the magnitude of h of omega is become 1. So let's mark that. At 0 frequency, its magnitude is 1. Now, if I replace omega tends to infinity, means in place of omega, we just replace infinite, then magnitude of h of omega is become how much? That is become 0 because it is become 1 over infinite. 1 over infinite is how much? That is 0. And if I go for the angle of h of omega, that is become 90 degree. Minus 90 degree, not 90 degree, minus 90 degree, because tan inverse infinite is will give you 90 degree and minus is outside. So if I draw the magnitude curve here, that will be look like this one. At infinite frequency, its magnitude is going to be 0, and at 0 frequency, its magnitude will be 1. So if you remember in yesterday class, I told you that this RC filter is a low pass filter. Remember the first example where I gave you that this is a RC filter and it will work a low pass filter. Why it will work a low pass filter? Because at lower frequency its gain is 1. Means if you apply a lower 0 frequency or lower frequency, it will have a gain 1. It means it will pass that frequency effectively. Right? And at higher frequencies its gain is very low. At higher frequency, its gain is very low, means at very high frequency, its gain is almost zero. So it means it is only passing the low frequency signal through this one. Right? It means this filter is generally known as low pass filter. So if you are having a circuit like this, now this is the brief and complete detailed discussion about that one, how it will be work. So we have to check only two frequencies. At 0 frequency, how much is the gain of circuit, right? It is 1, like it will pass the lower frequencies, and at high frequency, its gain is going to be 0. It means it will be work like a low pass filter. Check and let me know. Understood everyone or not? Yes, please check this. Should I repeat anything? Just let me know. I will repeat that thing again. Okay, this is the second example that's for you. You have to check that which type of filter is this one. Right, the same thing I interchange R and C. Right, you have to check that one. Which type of filter is this one? The same procedure you have to follow for that one, and just make a simple note on that one. when after getting this example that if I see this circuit, this is a low pass filter. If I see that circuit, it will be a high pass filter like that. Any doubt in these two topics? Just let me know. Right? It's the same process which we followed in the for the previous example. You have to do by yourself. Solution is already there here. Clear this lecture or not? I'm moving to the next topic. Yes. Just please ask if you have any doubt in on this one. Yes. The next topic which we are going to discuss that is most important and you should be aware about that one, that is Fourier series and Fourier transform. Fourier series and Fourier transform. Now, as you know, we already discussed there are two domains. The one domain is time domain and another domain is frequency domain. One domain is time domain, another one is frequency domain, right? So basically, whenever you are converting a signal from time domain to frequency domain, there are two tools to do that. That is Fourier series. Another one is Fourier transform. Like some persons are already aware about this Fourier series and Fourier transform, but most of the person that thinking that this is the new term for us. So again, I'm going from the basics and we will discuss that one, right? So the first thing which we are going to discuss, that is Fourier series. That is Fourier series. Okay, before moving to Fourier series, let me discuss about the filters. Let me discuss about the filters. Yes. The first type of filter is low pass filter. After that, we are going to discuss about this Fourier series and Fourier transform. The first thing you should know, we are having four type of filters. Filters means what? Filter is a any circuit which will pass a certain part of frequency, reject the other part of frequencies. Right? That is a filter. So basically, first thing which we have, that is a low pass filter. If I'm talking about low pass filter, low pass, what the name suggests, low pass, it means it will pass the lower frequency. It will pass the lower frequency and it will reject the frequency above a certain frequency. So basically, there is a certain frequency. After that, it will reject all the frequencies. Right, there is a certain frequency. After that, it will reject all the frequencies. It means that frequency is generally known as cutoff frequency. I am again repeating the definition of cutoff frequency. Cutoff frequency of any filter. Cutoff frequency of any filter is the frequency after which like if I'm taking an example of low pass filter, the cutoff frequency of a low pass filter is the frequency after which it will remove all the frequency, it will pass all the frequency up to that cutoff frequency. So low pass filter means what? Which will pass the lower frequencies below the cutoff frequency and reject all the frequency above that cutoff frequency, right? So if you see the h of omega spectrum, like this, right, in frequency domain, so it means this is a low pass filter. At zero frequency its gain is 1, at infinite frequency its gain is 0. So generally if you are seeing that at omega equals to 0 the gain is 1, and at omega equals to infinity gain is 0, then what we can suggest, that this filter is always low pass filter. So we have to calculate the given filter gain at omega equals to 0 and omega equals to infinite. Then we will only understand that it is a low pass filter. High pass filter, for a high pass filter, the gain at omega equals to 0. See what you are observing here. Below this cutoff frequency, the gain is 0. It means it will reject all the frequency below this cutoff frequency, and it will pass all the frequency above this cutoff frequency. So it means this spectrum suggests that this is a high pass filter. This is a high pass filter. When you see the high pass filter, it means it will reject all the frequencies up to cutoff frequency, and it will pass all the frequency above cutoff frequency. Next thing is band pass filter. Next thing is band pass filter. Generally when we talk about the band pass filter, the band pass filter will have two cutoff frequencies. Always remember, band pass and band stop filters have two cutoff frequencies. If we are talking about band pass filter, it will have two cutoff frequency, omega C1, omega C2. Right? It will, what will be the name suggest, that is band pass filter. It means it will pass a particular band of frequency and reject other frequencies. It will pass the particular band of frequency, like from omega C1 to omega C2 it will pass, but it will reject all other frequencies other than that. So that means this is a band pass filter, right? Okay, in this high pass filter, what we observe, that the gain of this one at omega 0 is 0, but gain of this filter at omega equals to infinite will be 1. So that means if any filter will have this property, means gain at 0 is 0, gain at infinity is 1, that means this will suggest you that this is a high pass filter. This is a high pass filter. Now if I'm talking about this band pass filter means what? It will pass a particular band of frequency, it will reject the other band of frequencies. Now if I'm talking about this band pass filter, then yes, Abhinav, you can say like that. If you want to, let us take you are saying something, so it will be having some certain amount of frequency inside that one. And if you want to remove some amount of frequency, let us take an example. You will better understand that one. Like I'm having a voice signal like this. This is a voice signal, and up to this frequency, let us take it is 20 kilohertz, right? Up to this frequency I want to only that this frequency will pass, and these frequencies no use for us, so we want to remove these frequencies. So what we do, we will pass this voice signal through a low pass filter whose cutoff frequency is 20 kilohertz. So 20 kilohertz, up to 20 kilohertz this signal will be passed. The voice signal which is having the frequency component from 0 to 20 kilohertz, that will be passed by this low pass filter, and it will be reject all other frequencies, right? So these are the frequency, means this is the use of low pass filter. If you want a certain only these frequencies I want to pass, means I want that only 10 to 15 kilohertz frequencies are available in my output. So what should I do? I will use a band pass filter so that it will pass only these frequencies from 10 to 15 kilohertz. Did you understand what the filtering means? Filtering means we want to select a certain amount of frequency that these will pass, all other frequencies will reject. Clear now, Abhinav? So these are the type of filters. There are four types of filters. The first one is low pass filter. I already told you that thing, that low pass filter will pass the lower frequencies from 0 to omega c. Omega c is generally known as what? Cutoff frequency. And another one is what? High pass filter. High pass filter means what? Which will pass the frequencies from omega c to infinite, means all the frequencies which are above or greater than this omega c. it will pass them, and it will reject frequencies from 0 to omega c, right? That is a high pass filter. Band pass means which will pass the particular band of frequency, that will be band pass filter. Okay, if you are talking about the gain of this band pass filter at omega equals to 0, that is 0, and gain of this band pass filter at infinity is also 0. That means it will pass a particular band of frequency in between these two frequencies, right? That's why it is called as band pass filter. Okay, now the last one is band stop filter. If you want to remove, if you wanted to remove a certain band of frequency from a set of frequencies, right? So for that purpose we will use the band stop filter. Band stop filter will also have omega c1, omega c2, so it will reject the band from omega c1 to omega c2 and pass all other frequency. That's why it is named as band stop filter. It will stop a particular band of frequency, right? So that is all about this filtering. There are 4 types of filtering, and generally these filters are only LTI systems. These are LTI systems.
पर
Yes, please.
ये नॉच फिल्टर को बैंड स्टॉप फिल्टर को ही बोलते हैं का नॉच फिल्टर?
हाँ जी, नॉच फिल्टर बैंड स्टॉप फिल्टर का एक स्पेशल टाइप होता है। जब ओमेगा C1 और ओमेगा C2 इक्वल हो जाएंगे, वो एक पर्टिकुलर फ्रीक्वेंसी को स्टॉप करने के लिए यूज किया जाता है।
एक चेबे की कुछ करके है सर, याद नहीं आ रहा है, कुछ एग्जाम में दिए थे तो एक चेबे करके कुछ आया था, भूल रहे हैं
क्या आया था?
कुछ करके, याद नहीं आ रहा अच्छा से, चेबे लिखा हुआ
चेबीशेव
था।
फिल्टर।
वो आगे
चेबीशेव।
आएंगे, अभी अभी करेंगे। बटरवर्थ फिल्टर, चेबीशेव फिल्टर आगे आएंगे, अभी वो जब डिजाइनिंग करेंगे एनालॉग फिल्टर्स की, अभी पढ़ेंगे उनको, राइट? वो ये लो पास फिल्टर, बैंड पास फिल्टर डिजाइन करने के कुछ मेथड्स हैं प्रैक्टिकल केसेस के अंदर। ठीक है, तो कल हम लोग फोरियर सीरीज स्टार्ट करेंगे भाई डिटेल में। फोरियर सीरीज, पीरियोडिक फंक्शंस पहले डिस्कस करेंगे, फिर फोरियर सीरीज, देन वी विल गो टू द फोरियर ट्रांसफॉर्म। आज जो किया है इसमें कोई डाउट हो तो पूछिए, कोई भी डाउट हो।
और देख के कैसे पहचानेंगे हाई पास फिल्टर है लो पास फिल्टर है?
हाँ जी, क्या कह रहे हो, रिपीट करो।
मतलब ये सर्किट दिया रहेगा तो देख के कैसे पहचान लेंगे हाई पास फिल्टर है लो पास फिल्टर है? उसको
वो
चेक
कैसे
ही
पहचान
करना
लेंगे?
पड़ेगा सर?
हाँ जी, समझाया पीछे ना पूरा डिटेल में, जैसे वो किया था अभी।
हाँ,
जैसे
वो तो
पीछे क्या
लंबा।
था, हाँ, एच
हाँ
ऑफ
वो
ओमेगा
सर समझ
निकालेंगे।
गया।
एच ऑफ ओमेगा निकालने के बाद जीरो पे निकालना है, इनफाइनाइट पे निकालना है। तो अगर इससे मैच हो रहा होगा, तभी ये लिखा रहा हूँ भाई मैं यहाँ पे। अगर
हाँ
इससे
ये
मैच होगा, हाँ जी बताइए।
वो वो समझ गए सर, वो तो प्रोसेस समझ गए, लेकिन डायरेक्ट नहीं हो सकता, हम तो देख के हम पहचान सकते हैं कि
याद करना
पार्लर में
पड़ेगा।
लगा हुआ है, तो याद करना
याद
पड़ेगा सर।
याद करना पड़ेगा फिर, अगर आपको याद
ओके
करना।
सर।
अदरवाइज आप डायरेक्टली ये जीरो पे निकालो, इनफाइनाइट पे निकालो, आपको फिल्टर डायरेक्टली पता चल जाएगा कौन सा फिल्टर है। एनी अदर डाउट? Okay, Ankit. So tomorrow you have to get the basic idea about the periodic signal, and after that we will go to the Fourier series and Fourier transform. We will try to finish them tomorrow. Okay then. See you tomorrow. If anyone have any doubt, then please ask. I think everything is clear to everyone, right? Okay.